Welcome to another deep dive where we're going to explore AI, but through a lens you might not expect, casinos.
Casinos.
I know, right? It sounds a little crazy, but trust me, using the world of gambling is a surprisingly fun way to wrap our heads around some pretty complex AI concepts.
Yeah, it's all about finding that relatable hook, right? We're not actually teaching you how to be a card shark here, but using these familiar ideas of betting and odds to kind of demystify the math behind AI.
Right. Our source material for this deep dive dives into three main areas of math: calculus, linear algebra, and probability and statistics.
A lot of math.
Yeah. And it's a document originally written in Chinese, so the English translation can be a bit unusual at times.
Yeah,
Which actually makes it even more intriguing.
it does add a certain flavor to it.
So get ready to discover how AI thinks using calculus, just like a gambler adjusting their bets at a poker table. We'll see how slot machines are surprisingly similar to AI's neural networks, and how AI uses probability, not certainty, to make decisions, just like in a high-stakes poker game.
It's fascinating how these parallels emerge.
Totally. Okay, let's start with calculus. This is all about how AI learns and evolves, constantly refining itself to become more accurate. And you know what plays a key role in this?
Derivatives.
Derivative.
Derivatives.
Yeah, essentially derivatives are all about understanding change. Imagine you're playing a slot machine, but instead of coins, you're feeding it data. Each pull is like a learning attempt, and the derivative helps AI understand how those tiny changes in its thinking, affect its accuracy.
So if AI is like a gambler, then the derivative is its strategy guide, helping it place smarter bets, right?
That's a great way to put it. The source uses a seesaw analogy to explain this.
Yeah.
Remember how, one side going down makes the other go up? That relationship, the rate of change between the input and the output, that's what the derivative is capturing.
Okay, I'm starting to see the connection. But can we make this even more concrete? Absolutely. The source gives this great example using coins and a slot machine. You put in X coins and you get Y winnings. The relationship between those is a function, like fx. The derivative, written as f prime of x, tells us how much your winnings change for each extra coin you put in.
So it's like, is this slot machine even worth playing? Should I keep feeding it coins?
Exactly. So in one scenario, adding a coin might lead to more winnings, a positive derivative. But what if adding a coin makes you lose even more? That's a negative derivative. And it's a sign that your strategy needs adjusting.
I'm starting to see how this applies to AI. It's constantly looking for that positive derivative, that sign that it's on the right track.
Precisely. It's like a continuous feedback loop. And the source even mentions this golden rule: follow the derivative. If it's positive, keep going in that direction. If it's negative, try something else.
It's like AI is running its own little experiments, learning from its mistakes, and refining its approach with each try.
That's a great way to think about it. And just like gamblers have different betting styles, AI has something called a learning rate. A high learning rate is like being an aggressive gambler, making big adjustments but potentially missing the mark. A low learning rate is more cautious, making smaller adjustments.
So it's all about finding that sweet spot, that balance between boldness and caution, just like a skilled poker player.
Absolutely. AI is constantly trying to strike that balance as it learns and adapts. Now, our source even provides a bit of Python code to demonstrate how this works in practice.
Oh, cool.
But the key takeaway here is that AI uses derivatives, these tiny nudges, to constantly improve. Just like a gambler fine-tunes their strategy based on experience.
Okay, that makes sense. But what about the chain rule? That sounds a bit more complex.
It is, but the source breaks it down beautifully using, again, a casino analogy. Imagine the casino decides to change the payout on a particular slot machine. That change doesn't just affect that one machine. It can ripple through the entire system, impacting players' profits, everything. That's the essence of the chain rule. A domino effect.
Okay, I'm intrigued. Give me an example.
Okay. The source describes a multi-level slot machine. Imagine there are 3 levels: bronze, silver, and gold. Think of them like layers in a neural network.
Okay.
You win coins at the bronze level, those coins feed into the silver level, and then finally the gold level where you get your final payout.
So it's like a chain reaction of wins moving up the levels. I can already see how this might relate to neural networks with data flowing through different layers.
You got it. Each level has its own multiplier, just like different parts of a neural network contribute differently to the final output. And the way those multipliers interact, how those effects cascade through the system, that's where the chain rule comes in.
This is fascinating. How does this play out in real-world AI scenarios?
So imagine a player thinks they should have won more. There's a bonus dispute. The casino needs to figure out where the error occurred. Was it at the bronze, silver, or gold level? This is remarkably similar to how AI uses a process called backpropagation to pinpoint errors in its network.
So the chain rule acts like a detective, tracing back through each layer to identify the source of the problem.
Exactly. And just like the casino might adjust the multipliers on the slot machines to correct the error, AI uses the chain rule to adjust the weights in its network to improve accuracy.
Okay, that's super cool. So the chain rule helps AI not only learn, but also debug and refine its learning process.
Precisely. It's a powerful tool for understanding and optimizing complex systems, whether it's a multi-level slot machine or a deep neural network.
All right, we've covered derivatives and the chain rule. What's next on our calculus journey?
Let's talk about integrals.
Integrals.
This might sound intimidating,
A little bit.
but think of it this way. You've been at the casino all night, and now you're adding up your total winnings or maybe losses.
Yeah.
You're not focusing on each individual win or loss, but the overall outcome. That's integration.
It's like getting the big picture, the net result of all those individual bets.
Exactly. It's about taking a step back and seeing the overall trend. And in AI, integrals are used to look at the overall learning progress. Instead of focusing on each tiny step, you're evaluating how well the AI is learning over time. It's like smoothing out the learning curve, seeing the forest for the trees.
So instead of obsessing over every win or loss, we're looking at the overall trajectory.
Exactly. Now, you might be wondering how these two concepts, derivatives and integrals, work together. That's where the very elegant, fundamental theorem of calculus comes in.
Let's hear it.
Okay, imagine you're playing blackjack. The derivative is like checking your win-loss rate at any given moment, like a snapshot of your current performance. The integral, on the other hand, is calculating your total profit for the night, giving you a broader perspective.
So it's like the derivative is the short-term view and the integral is the long-term view. Both important, but for different reasons.
Precisely. And our source brings up a fantastic real-life example. Ed Thorpe, a mathematician who developed a legendary blackjack strategy. He actually used derivatives to figure out probabilities and adjust his bets in real time, a bit like AI uses gradient ascent to optimize its learning.
Wait, so he was basically a human AI using math to beat the system.
Right.
That's incredible.
And to make sure his approach was profitable in the long run, he used integrals, running thousands of simulated blackjack games to see how his strategy performed over time. He was a pioneer in using math to understand and master games of chance.
So what's the big takeaway here?
Both derivatives for those micro adjustments and integrals for that big picture understanding are essential for successful strategies. Whether you're playing cards or training AI, it's about balancing short-term tactics with long-term goals.
And that's how AI uses both. Derivatives help it make those gradual improvements during training, while integrals ensure it's on the right path overall. It's like a delicate dance between fine-tuning and taking the long view.
It truly is.
Yeah.
And that wraps up our exploration of calculus in the world of AI. It's amazing how something as seemingly abstract as calculus can be understood through the lens of something as familiar and exciting as gambling.
Totally. It's like we've decoded a secret language. Stay tuned, because up next we're diving into the world of linear algebra, and I have a feeling it's going to be just as mind-blowing. All right, we just finished exploring how AI uses calculus to learn and optimize, just like a gambler refining their strategy. Now we're stepping into the world of linear algebra. And I'll be honest, this one always seemed a bit more intimidating to me. Matrices, vectors, it all felt very abstract.
It's true, linear algebra can seem a bit daunting at first, but it's actually the language that AI uses to understand information. Think of it this way. AI works with numbers. Everything from the photos on your phone to the music you stream, even those facial recognition systems you see at casinos, it all gets converted into matrices, these grids of numbers for AI to process.
So instead of seeing a picture of a cat, AI sees a bunch of numbers that represent that image.
Yeah.
It's like a secret code.
Exactly. AI sees the world through this numerical lens, which might sound strange, but it's incredibly powerful. And one of the key tools in this numerical world is the concept of vectors.
Okay, vectors. I vaguely remember those from high school math, something about arrows and directions. But how do they fit into all of this? And what does this have to do with casinos?
Okay, imagine you're at a roulette table, and you decide to bet $5 on red, $10 on black, and $2 on green. That right there is a vector. It's a list of numbers that represents not only the amounts, but also the specific categories you're betting on.
So it's not just about the numbers themselves, but what those numbers represent.
Exactly.
That's interesting.
AI uses vectors to represent all sorts of information. For example, think about those word suggestions that pop up when you're typing a text message. Those suggestions are based on how words relate to each other, and those relationships are represented using vectors.
So each word is like a bet on a roulette wheel, and the vector shows how those words are connected. It's like AI is playing a giant word game.
That's a great analogy. And it's not just words. Think about how Netflix recommends movies you might like. They use vectors in a space called Hilbert space to find movies similar to what you've watched before.
Wait, Hilbert space. That sounds incredibly complex. Is that another one of those infinite casino things?
You're catching on. Remember how we talked about integrals giving us a big picture view? Well, Hilbert space is like having a casino with infinite gambling tables, each representing a different piece of information.
Okay, I'm trying to picture this. Infinite tables, each with its own game. It sounds like a gambler's dream, or maybe a nightmare if you can't keep track of it all.
It is a lot to wrap your head around. But the key is that each table in this infinite casino is like a basis vector, a fundamental building block. And just like a gambler might spread their bets across different tables, AI can combine these basis vectors to represent complex data.
So it's like AI is playing a massive game across all these tables, figuring out the best combination of bets, or in this case, the best way to represent and understand the information.
Exactly. Hilbert space provides a framework for AI to navigate this vast landscape of data, find patterns, and make connections. It might seem abstract, but it's the foundation for some of the most impressive AI applications we see today.
Okay, I'm starting to get a glimpse of how powerful linear algebra can be. But we still have one more area of math to explore: probability and statistics. This one feels a bit more familiar given that casinos are all about odds and chance, right?
Absolutely. And AI uses probability in a similar way to make predictions and generate content. But here's the key difference. AI doesn't know things for sure. It calculates probabilities based on the data it has. It's like a master poker player, constantly assessing the likelihood of different outcomes and making strategic decisions based on those probabilities.
So instead of saying, this is definitely a picture of a cat, AI would say, there's a 90% chance this is a cat.
Exactly. It's all about working with uncertainty and making informed decisions based on the available evidence. And one of the most important tools for this is Bayes' theorem.
Okay, Bayes' theorem. I've heard of it, but can you remind me how it works? And how does this relate to our casino theme?
Imagine you're playing Texas Hold'em, and you've noticed that a particular player tends to bluff about 60% of the time. That's your prior probability. But suddenly, they place a massive bet. This new piece of information changes things. Now, the probability of them bluffing might jump to 80%. That updated probability is called the posterior probability.
So Bayes' theorem is all about updating our beliefs based on new information. The more we observe, the more refined our understanding becomes.
You got it. And AI uses this principle constantly. Think about those spam filters that get better over time. They're using Bayes' theorem to update their understanding of what constitutes spam based on the emails you mark as junk. It's a continuous learning process.
So my spam filter is basically a poker player, learning to spot bluffs and make better decisions over time. That's actually pretty cool. What other probability tools does AI have up its sleeve?
One of the most common and powerful is the Gaussian distribution, which you might know as the bell curve.
Ugh. The bell curve. I remember that from statistics class.
Yeah.
It's all about how data tends to cluster around the average. How does AI use that?
Imagine a casino where most players lose about $100 per night, with a few lucky or unlucky outliers winning or losing much more. That distribution of wins and losses would likely form a bell-shaped curve, a Gaussian distribution.
So AI uses probability distributions like the Gaussian to model real-world data and make predictions.
Exactly. And the bell curve is particularly useful because it allows AI to handle uncertainty in a consistent way. It's used in everything from image recognition, where AI might need to account for variations in lighting or angles, to speech recognition, where it needs to filter out background noise.
It's like AI is using the bell curve to say, I'm not 100% certain, but based on the data I have, this is the most likely scenario.
Precisely. And that ability to deal with uncertainty is what makes AI so powerful and adaptable. It's not about finding the perfect answer every time. It's about making the most informed decisions based on the available data.
This has been an incredible journey through the world of linear algebra and probability. Who knew that something as seemingly abstract as math could be so deeply connected to something as tangible as casinos and gambling?
It's all about finding those unexpected connections, isn't it? And now that we've explored these foundational mathematical concepts, I think we're ready to tackle the big question. What does this all mean for us in a world increasingly shaped by AI?
I'm ready to dive into that. Let's wrap up our deep dive by exploring the implications of all this incredible AI power. Wow, we've been on quite a journey, haven't we? We saw how AI uses calculus to learn and optimize, just like a gambler refining their strategy at the casino.
Uh-huh.
Then we explored linear algebra, the language of vectors and matrices.
Yeah.
This allows AI to perceive and process information in a way that's completely different from how we humans see the world.
Right.
And finally, we uncovered how AI leverages probability, embracing uncertainty to make predictions, generate content, just like a master poker player sizing up their opponents at the table.
It really is remarkable how these seemingly complex math concepts can suddenly become so tangible and relatable when we look at them through casinos and gambling.
Totally. It's like we've been given a backstage pass to the inner workings of AI, seeing all the gears turning and understanding the strategies it uses.
Yeah.
But now that we have this newfound understanding, a big question emerges. What does all of this mean for us? How does this knowledge equip us to navigate a world where AI is playing an increasingly prominent role?
Yeah. That is the million-dollar question, and it's one that we all need to grapple with, especially as AI continues to evolve at such a rapid pace.
You know, when we started this deep dive, I have to admit I was a little intimidated by all of this. Calculus, linear algebra, Hilbert spaces.
Yeah.
It all sounded very abstract and complex.
Right.
But now I feel a sense of empowerment.
Oh, that's great.
It's like I've been given a new set of tools to understand and analyze these AI-powered systems that are becoming so prevalent in our lives.
I completely agree.
Like knowledge is power.
Right.
And understanding the fundamental principles behind AI, it allows us to engage with it in a much more critical and thoughtful way.
It does.
We can ask better questions, challenge assumptions, and make informed decisions about how we want AI to actually shape our future.
Yeah, that's a good point. This knowledge really empowers us to move beyond just, a sense of awe or even fear of AI
Yeah.
and engage with it as informed citizens. We can participate in these important conversations about responsible development and deployment of AI and ensure that it's actually used for good, right?
Absolutely.
And doesn't just perpetuate existing inequalities or create new ones.
I never thought that a deep dive into the world of casinos would lead to such profound insights about the future of AI
Right.
and our role in shaping that future. It's truly mind-blowing.
It is fascinating how these seemingly unrelated fields, they can intersect and illuminate one another.
They do.
And our source material actually encourages us to continue exploring these connections. They even offer some additional resources like a blackjack strategy trainer and a poker hand data set for those who want to dive even deeper into the math behind it all.
It's like we've been handed this treasure map, and it's up to us to continue the exploration, to keep learning and challenging ourselves to really understand this ever-evolving landscape.
And who knows what fascinating discoveries await us along the way, right?
Right.
Just like in a casino, the real thrill lies in the unknown, the possibility of uncovering new insights and strategies that could change the game entirely.
So well said. This deep dive has given me a lot to think about, and I'm really excited to continue exploring the world of AI, especially now with this newfound understanding. Thanks for joining me on this adventure.
The pleasure was all mine. Remember, listeners, in the age of AI, the key to success is to stay curious, keep learning, and never stop questioning those algorithms. Until next time, keep those minds sharp and those chips stacked high.